Okay, so we are starting with part 2 of section 1-3, talking about segments and adding them together. So we're talking about the segment addition postulate, which states that if we have 3 points, so A, B, and C, and they're on the same line, so I have a line drawn and I'm going to place A, B, and C, and B is in between A and C, so I have A and C, and then B, point B is somewhere in between, doesn't matter where for the moment, I just had one ready. Then I know that AB, so segment AB, plus BC if we add those two segments together, we know that they are going to add up to the whole AC. So the segment addition postulate is basically like part plus part equals the whole. That's what we're looking at here. And if I look at our first example, we're going to use the segment addition postulate to help us find the parts of our segments. So if I have segment EG, and we're saying that EG is 59 units, I need to find the two parts, EF and FG. Using the segment addition postulate, I know that EF plus FG should equal the whole segment EG. Now, we were given the info about EF and FG, this 8x minus 14 and 4x plus 1. So instead of having EF, I'm now going to replace it with 8x minus 14 plus FG, which is now going to be 4x plus 1. And instead of having EG, I'm going to use the 59 that it's also equal to. Now we've just got an equation where we need to solve for x. Sometimes you'll have y, whatever variable you have. At this point, we're going to be solving for the variable. Now, reminder about solving for x when you have terms that you can combine on the same side, you would just add them and we'll get 12x. Other like terms we're going to combine, negative 14 and 1, we get minus 13 equals 59. Now to move something to the other side of the equal sign, I see that 13. I use the inverse operation, so I add instead of subtracting, so I can cancel out that 13. And I get 12x is equal to 72. The 12 and the x are being multiplied. The inverse would be to divide by 12, and I get x is equal to 6. So I found x. What does that help me do? It actually helps me find EF and FG because I have EF and FG in terms of x now. So I'm going to plug in x equals 6 into both EF and FG, those expressions, so I can find out what those lengths are. So I plug in 6, 48 minus 14, and so I know that EF is equal to 34. And now we're going to find FG by taking x equals 6 and plugging that in. So 4 times 6 instead of 4 times x plus 1, 24 plus 1. So FG is equal to 25. All right, and that's how we're going to use our segment addition. We add our two parts, it equals the whole. That helps us solve for our missing variable, and then we can plug it back in. What we're actually looking at right now is the idea that we also have like congruent segments. Basically, if I know that CD and AB have the same length, so let's say the tick marks mean same length. Let's say it's 3 inches, 3 inches. I can say that AB is congruent to CD. So congruency means lengths are the same. So these are the two ways we can write that. And we'll have another video on the midpoint and segment